Welcome to Lesson 9, Electrical Energy, Activity 9.3. And if you took a look in your book on page 103, and I'll tell you what you're going to do with page 103 in a little bit, you'll see that there's not much there. So our learning target for today is we're going to investigate how electricity can be produced. And by the end of the day, I would expect you to be able to explain how electricity can be produced or created. Now, one of two things happen. Either this lesson is flipped because I'm not here and you watched a video and you completed the questions with the video, or I'm here and I'm doing this live and I do a demonstration for you. Now, before we do any demonstration, what is the source of electrical energy in your home? So think about this. If you're in your house, when you flip on the switch, I know a lot of people say, what's the source of electrical energy in your home? And they'll say, oh, the outlet or the light switch, the wires, the walls. Well, not really. Even though wall sockets, solar panels, plugs, cords, and generators, that's where you get your energy from in your house. We have to look at something much deeper. Where does the energy come? Where does the electricity come that comes into your house? So when you plug something into the wall socket, when you flip the switch, electricity it runs your TV, it lights up your house. So where does that electricity come from? We're going to take a look at that today. So how does it get to your home? So how does this electricity get to your home? If you said from cables or large wires, you're correct. Now, in the old days when I was young, almost all electricity was transported via large cables, wires, transmission lines, electrical lines. There's lots of different names for it. But nowadays, a lot of these are actually buried. And one of the good things about that is we tend not to lose as much electricity during the winter. When I was a kid, and I know I'm dating myself, way back in the 70s and 80s, we lost electricity 5-6 times every winter because the ice would build up on the transmission lines and they would fall. But now with so many transmission lines buried, it's a lot harder for that to happen. Now, do batteries somewhere supply electrical energy in your home? They could. Even though batteries aren't sufficient for supplying electricity to your whole home. And I'll caution myself right there and stop. Some homes are off the grid, and if that's the case, they may have enough batteries built up where they can power their entire house via batteries. However, instead, huge generators produce electrical energy. Electrical energy is transferred from power plants to homes. Again, I'll stop myself. Some homes have their own backup generators. Especially if you live out in the country, it's a good idea to have a backup generator, especially if you live on a farm. Because if you have to milk the cows in the morning, if you don't have electricity, you still have to milk the cows. So most farms these days have generators. So this is what a generator might look like. This is a simplified version. This isn't the type of generator you're going to find in the Columbia Power Plant over by Portage, or in the hydroelectric power plants that we have in Wisconsin Dells or in Prairie du Sac. This is just a very simplistic design. It's got a crankshaft, it's got a magnet, it's got an armature, it's got a light bulb. And what would happen is if I cranked this, it would light up. And the videos that you watched, if you watched the flip lessons, told you how that works. If I'm doing this live, I would have already explained how that works as well. So either I'm doing it live and you'll get that information, or you'll get it from the video. So if you watched the video, this is the same picture that you saw in the video. And we'll come back to this picture in a little bit. So during the demonstration, again, if I'm live, these are the questions I'm going to ask you during the demonstration. If it was a flip lesson, you already watched a video on it. So what is the evidence that electricity is produced? Well, either way, if I did it live or if you watched a video, the light bulb would light up. That's your evidence that those electrons are flowing. Now, when a crank is moved, why does the intensity of the light of the bulb vary? Well, if I did it live, I turned it really slowly, and as I turn it faster, the light bulb gets brighter. And that's because there's more and more electrons. So the amount of kinetic energy being transformed into electrical energy varies as the crank is turned faster and slower. The number of electrons that are flowing increases and decreases as that happens. So which energy transformation occurs in this demonstration? Well, you're going to have KE to electrical energy, to light, and then back to thermal energy. So not necessarily like the thermal energy, but the electrical energy, the light bulb's going to light up, and it's also going to get warm. So if you were going to touch that light bulb after a little while, you could potentially burn your fingers. So post demonstration, again, what kind of energy transformation happens inside a generator? Well, you've got the KE. If you watched a flip lesson, you saw that the wind was creating the mechanical energy. If you watched it live in class, you saw that it was the crankshaft. In other words, it was mechanical energy, my strength, that turned the crank, and that created the KE. And that KE is being converted into electrical energy. So what is the source of energy in a commercial generator? Well, it's usually a turbine, but if you have a generator in your backyard, or if you have a hybrid that may have a generator in it, it could be gasoline or a diesel engine. So it could vary, but when you see all these big wind turbines, it could be wind. Usually in a lot of cases, it's steam. So electrical energy is the energy carried by electrons moving through a conductor. This motion is called the electrical current. There are two conditions for electrical energy to be present. First, you have to have a closed conducting circuit, and you must have an energy source. Now, electrical circuits can transfer energy from a source to electrical devices, where it can be transformed to other types of energy. So does anybody have any questions? Now let's back up. What do I want you to draw on page 103? What I want you to do is you're going to draw for me what a generator looks like. So if you want to make it like this, where you have the crank, you have the magnets, you have the armature, you have the light bulb, or you could draw this. So here you have the magnets, okay, creating your magnetic field. Here you have the wind turbine creating your mechanical energy. You have your light bulb. Here you have your brushes. And if you want to go back to the video that you watched, you can actually get all the names of this as well. So what you're going to do is you're going to have a drawing on page 103 of an electrical generator. And so this would be the easiest one to draw right here. So what's going to happen? Also, you're going to have to be able to explain how electricity is generated. So something spins this. It could be mechanical energy, it could be wind, it can be water. It spins the shaft here that is going to be spinning this in circles. So it'll be going around and around and around. And as it spins, it creates an electrical current that goes through the wires, then that goes into the generator. And then those electrons are flowing from one piece through the light bulb, through the other wire, back into create the electricity. Now, if you're watching this video and you hear a lot of noise, it's because one of my sons, actually both my sons, are having a party right now, so there's kids running around. So I apologize if there's any noise. So again, get this drawn in page 103. Then what I want you to do is go to the front of your book, and I want you to add these two scientific principles. Number 17, electrical energy can be transformed into other types of energy in a closed conducting circuit with an energy source. And then 18, a battery transforms chemical energy into electrical energy. A generator transforms KE into electrical energy. So go ahead, I'll be checking to make sure that you have these in your book, and that'll tell me that you actually watched the video and you did what you were supposed to do. So again, as always, if you were absent, if you weren't here, if you watched a video, make sure you ask questions so you know exactly what these scientific principles mean prior to the test. Thanks.